The first question asks you to draw Lewis structures for the following. The first one is NO3 minus, which is also known as nitrate. I know that N has 5 valence electrons, and 6 O's, or 3 O's, each have 6 valence electrons. And we've got a -1 charge, so that gives me a total of 18 plus 5 is 23 plus 1 is 24 valence electrons. Now, once I have that information right here, once I have this information, I kind of just forget about it. And I'm going to recheck it later. So I'm going to go ahead and try to draw this. Well, I know N is my central atom because it's the first one named, and it also is the logical one because the other 3 are attaching themselves to it. I'm going to try to do this by using only singly bonded bonds. And so I've got 6 more for this O that it needs, 6 more for this O, 6 more for this O, and 2 more on that N. And now I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this one doesn't work. So now I'm left to try it over again. I've got N, O, O, but this time I'm going to try it with one of them being a double bond. Now, this O only has 2 electrons, so it needs 6 more. Now it's got its 8. This O over here has 4 electrons, and so as a result, it only needs 4 more. This O also needs 6, and now this N over here has 2, 4, 6, 8. So it's satisfied. So now if we count up those electrons, now I refer back to this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So this one is perfect. The only thing I need to do is just kind of put this in brackets and put a -1 on the outside. And now I should be in good shape. Okay, let's move over to this one, CH4, which is also known as methane. This is a gas. Not important to know that necessarily, but just for your own edification. So I've got 4 plus 4 times 1 is 8 valence electrons. If I try it with just single bonds, and this is where it gets a little tricky, well, you might say, oh, well, this H only has 2 valence electrons, so it needs 6 more. But H's, remember, are in that first row. They want to be like helium, and helium only has 2 valence electrons. So just by bonding, it automatically does that. This carbon now has 8 valence electrons, and so this is what CH4 looks like. Let's skip ahead here. We've got NF3. Okay, so we've got N, which is 5, plus F, and 3 of those is 3 times 7, so this is a total of 26 valence electrons. And again, that information now, this, I'm going to kind of forget about. If you start getting hooked on this and start thinking about that when you draw, you can get all screwed up. So I've got N over to F, over to F, over to F. Each one of these F's needs 6 more valence electrons because they need a total of 8. And the N now needs 2 more. So now if I count it up, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We're in good shape. Don't need a charge on it. Didn't have a charge. SiO3. So I've got Si is my central atom. I'm going to try it with just single bonds over here. Oh, I forgot to count them up. So I've got 4 plus 3 times 6 plus 2 is 18, 22, 24. 24 valence electrons. I need 2 on that Si and 6 on each one of the O's. And if I count that up, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That didn't work. So now I'll go back and try it one more time. Si, double bond to an O, single bond to an O, single bond to another O. And again, this O only needs 4 because it already had 2, 4. I need 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And that matches my 24 up here. So I'm in good shape there. HCN. C is my central atom. Let's try it to a single bonded H, single bonded N. This C only has 4 valence electrons. This N only has 2 to start. And so I need to add some more. And when I count those up, do they add up to the number that I started with? Well, H started with 1 plus carbon is 4 plus nitrogen is 5, so this is a total of 10 valence electrons. And I can tell you right now I got more than 10. 2, 4, 6, 8, 10, 12, 14. 14 is not going to work very well. Let's try to add a double bond. Now here's the deal on this one. Can't add a double bond onto the H, because remember H can only take on a couple more. Or two pairs, or one pair, 2 valence electrons. So now let's count these up. 2, 4, 6, 8, 10, 12, and I only had 10 to start with. So those two are wrong. I'm just going to go ahead and erase those. Again, I've got 10 valence electrons. I kind of erase that. This time we're going to try it with a triple bond, and that's about as big a bond as we can get. That's as close as it's going to get. And I notice that H now has 2 valence electrons. Carbon has 8. Nitrogen has 6. So I need to add 2 more to that nitrogen. And now I've got 2, 4, 6, 8, 10. 10 valence electrons. That looks pretty good. Let's try one more. H2O, oxygen being the central atom. Oxygen's on the inside. I'm going to single bond it to an H. Single bonded to another H. This oxygen now has 2 pairs, which is 4 valence electrons. So I'm going to add 2 pair more. This is going to be water. Let's count them up and make sure. So over here, H, I've got 2 times 1 plus 1 times 6 is going to give me 8 valence electrons. So now let's count them up. 2, 4, 6, 8 valence electrons. There's water.